Hello, everyone. Welcome to today's webinar about the construction industry, what's new and what's next. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar is presented by Gordian. Before we get started, I'd like to cover a few housekeeping items for you. First, please note the control panel on your screen. This is where you can submit questions via the question box in that panel. Please send your questions in at any time, and your speakers today will address them after the presentation. Also, please note the orange arrow on the left side of your control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure it is expanded so you can access that question box. Additionally, if at any time you experience a technical difficulty, please send a message to us in that question box and we will address it right away for you. Now I'd like to introduce your two speakers today. Tim Duggan is the Director of Analytics for Gordian, and he is currently leading the development of predictive cost data that will allow the construction industry to better estimate project value in the future. Additionally, analytics is deriving information around construction cost data that is allowing end users to compare market results to define metrics of interest. Tim earned a BS degree in mechanical engineering at New Jersey Institute of Technology, and he began his career as an engineer with the U.S. Army Research and Development Command. Your second speaker today is Ben Watkins. He's Vice President of Operations with McCarthy Building Companies. A graduate of Auburn University's College of Architecture, Design, and Construction, Ben has spent the majority of his career building healthcare and higher education facilities for clients that include Georgia Institute of Technology, Georgia State University, and Grady Hospital. Ben is a skilled project manager serving as the primary point of contact on McCarthy's most high-profile projects. Let's take a look at what trends will be covered in today's webinar first. You'll hear about trends toward more collaborative processes, qualified labor trends, advancements in technology, and construction cost data trends. So with that, I will hand it over to Ben. Welcome, Ben.
Thank you. Good afternoon, everyone. Appreciate the opportunity to talk to you today about some trends that I see in the construction industry. And when I was approached about doing this call, the first thing that came to mind to cover would be the delivery models that we're now working on. There's a definite trend within the construction industry to more collaborative processes. Situations where the CM and the architect and consultants are being hired at the beginning of the process before there's much design completed, and we're allowed to participate in that process, ultimately delivering a better result for our customers. So I wanted to just quickly go through the sort of the progression of delivery models that I've seen throughout my career. And as you go back into the, excuse me, I'm just doing the slides here. As you go back to the old traditional method of design, bid, build, I think, you know, we have all worked under that delivery model, and we've all seen some of the pitfalls that are there. But the primary one that I would say is the way that the contracting method creates silos amongst the different parties involved on the job. You've got the architect operating in a vacuum producing the documents. You've got a contractor operating in a vacuum pricing them, and then the owner trying to manage the two. Everyone has separate goals, separate ideas, and success looks different. Moving forward, and this is the one that we see most commonly, is the design build or design assist method. Lots of times the actual contract is called CM at risk here, but again, we are being hired before the design is completed. We are allowed to participate in the process of budgeting and the design, delivering feedback on constructability and other items that, you know, we can comment on during the design phase to ultimately deliver a better outcome. There's many different variations of this. People sometimes will call this IPD light, and that's a pretty good description. But the idea is the contractor is brought in early to help with the design phase and keep the project on budget and schedule. The third one on here is integrated project delivery, and this is the true IPD form. This is where we're seeing people come together, and the the contractor, the architect, and the owner will sign one single contract that aligns their goals. Very collaborative process, same type of a situation where we're all being hired, we're all signing that contract before the design has even really begun so that we can all participate. The fourth one that we put in here was job order contracting. This is also a collaborative process. This is sort of a way for owners to bring people on board when they're not 100% sure exactly what they'd like the contractor to do or what the projects might look like. Typically smaller projects. This is a way for owners to efficiently contract for design and construction services and execute small projects quickly. We'll talk a little bit about the shift to the more collaborative processes. Everybody wants their project done better, faster, and cheaper. And I can certainly understand that. I mean, as we move through the years, we want to learn from what we've done in the past, take those lessons, and ultimately deliver better products faster and cheaper. And I think that the way that we can do this is through a collaborative process. And that's why I think we're seeing this trend or shift to these different kinds of contracting methods. The terms of the contract under an IPD really drives the teams toward solutions or aligns the teams against common goals. And what it really allows us to do is maximize the value of the process and the efficiency at which we complete design and construction. The bottom line here is that, you know, all parties under an IPD agreement or a design build agreement are incentivized to complete the project against the common goals that I just mentioned a minute ago. And that is such a far cry from going out, creating documents in a vacuum, and then ultimately awarding a project to the lowest bidder, who will ultimately be trying to basically scratch and claw their way throughout the whole project to make sure that they don't have a bad outcome. A couple of the other values that I had were the team environment. You know, creating an environment in which people can collaborate and succeed is clearly advantageous, especially when you're talking about large, complex projects. Building meaningful relationships. This is huge. This is what our whole industry is about. When you really boil it down, it's about having relationships and being able to communicate effectively. And this shift in contracting methods is definitely a step in the right direction. I mentioned the objectives being aligned and the increased efficiency, but these are two inherent benefits. Are there any questions on this topic before we move into the next trend?
At the moment, no, Ben. Thank you.
Okay, thanks. So the next trend that I wanted to speak on briefly was labor trends in the Southeast region. I operate out of Atlanta here, and my area of responsibility is the Southeast region. And we've definitely seen some pretty significant swings in labor and what's available throughout the last couple of years. I'd like to back up to the recession that we dealt with here around the, let's just say, 2010 to 2012 area, maybe a little before that, a little bit after it, definitely seeing the effects. But what happened with the recession was, especially here in this region, is there was not a lot of work out there. The amount of construction that was happening significantly decreased. So what we saw was a lot of our labor force, our craft labor force, went into other industries. For example, maybe they moved up to Greenville, South Carolina, and went to work in a car plant or something of that nature. The after effect was now that we've got construction coming back, those people aren't necessarily running back to get back into the trades. So we're having to go about this different ways and trying to find out how we can, fill these craft labor positions. Also, mega jobs. Just here in Atlanta, over the last couple of years, we have 2 stadiums and 2 huge corporate headquarter jobs happening all simultaneously. So there's, inherently been a huge demand on labor as a result of those projects, and that has really, that coupled with the after effects of the recession, have created a huge demand crisis for craft labor here. Competing wages. Anytime there's a high demand, you're going to be dealing with a very competitive wage market, but we're seeing that there's a lot of people out there that are willing to pay $1 more here or $1 more there to get a crews that are willing to jump around from project to project, chasing a better wage. So our ability to manage that and wage people appropriately has been a huge focus item for us, and I don't really see that changing over the next few years. And then the last one I would just put is finding skilled labor. Our market here in the Southeast is predominantly a non-union market. We do have some union trades such as electrical, plumbing, pipe fitting, etc. And they have excellent craft training programs with those unions. The rest of our markets, we're having to fill in that gap, or trades, I should say. Various trades like carpentry, flooring, concrete, we end up with a lot of unskilled labor. So we're doing a number of different things to try to combat that. Craft education programs have become a really big deal. Just with McCarthy and the company that I work for specifically, we have a craft training program. We have a craft training center in Texas where we are training people to perform the crafts that we do a lot of on a self-performed basis, like concrete, steel, solar construction, a number of different things. So that's something that's a little bit different than what people have done in the past, which is a more reactive and on-the-job training kind of way of people learning, which ultimately is can sometimes sacrifice quality on a project. The other item I wanted to talk about here was just developing superintendents. Since we're down on craft labor, the old traditional way of developing superintendents was you picked out some of your guys in the trades who were good guys, were capable of managing people, and you move them up through the ranks and you train and develop them as career superintendents. Well, we still do that, but with not having as many people in the trades, those opportunities are much less than they used to be. So what we've done, and what I see across the industry as a trend here, is people developing a superintendent career path for the college graduate. A lot of in the past, if you were a college graduate and you went into the construction industry, it wasn't that common that you would stay as a superintendent for your whole career. Most of the people would try to become a project manager at some point and progress. So what we have done and other companies have done is develop a very compelling and exciting career path for people coming out of college who like the field, who like the nuts and bolts of putting the job together, true builders that want to do that for their whole career. And that has been a very, very effective way for us to deal with diminishing labor and the opportunity to develop superintendents through the through the trades. Does anyone have any questions on this topic?
We don't have any coming in yet, but we do invite our attendees to send them in. Thank you very much, Ben. And with that, we are going to have a poll. And that will show up on the screen. And we do ask you all out in the audience to please take a moment to cast your vote on this. Have you felt the impact of a shortage of qualified labor for your projects? Please just choose yes, it has affected my work. No, the shortage has not affected my work. Or not applicable. The labor shortage would not impact your line of work or your responsibilities at this point. So please just take a moment to cast your vote there. Have you felt that impact? And then we will move along. And the next trend we will hear about is technology after we review the results here. So let's see, more than half. Yes, it has affected my work. And we have about 25%, Ben and Tim. No, the shortage has not affected my work. And about 21% it would not impact. So, so there you go. Looks like we are seeing some impact out there. Thank you very much, everyone, for voting. And thank you, Ben. So with that, we'll now turn it over to Tim Duggan at Gordian, and he'll talk about some technology trends. Hi, Tim.
Hi, good afternoon. Thank you, everyone. And I'm waiting for the PowerPoint.
The technology topic, I think, was actually still mine, Tim.
Okay. Okay.
I could go ahead and expand on that one. But I do need control to go to the next slide. The other thing that I wanted to address on the webinar today in terms of trends are technology in construction. And it's very, very important for us to make sure that we stay on the cutting edge of what's out there and what's available. But what we try to do is really, really analyze all technology to see where it can add value for our customers. And when we see a place that it adds value, we try to jump in with both feet, figure it out, and ultimately work with our customers to implement it on our projects. One of the things that is out there now and becoming very, very popular is virtual design and construction, or VDC. BIM, or BIM, has been the buzzword here for a number of years. That's building information modeling. And that's not gone away. That is still part of what we do. VDC is more of a all-encompassing term. BIM falls underneath this. VDC kind of covers all of the technological aspects that we see in construction today. Next slide, please. The virtual reality options that are out there now. Sorry, I guess that was the last slide there on that topic, but there's a lot of options out there in terms of wearable virtual reality options. Oculus Rift and HTC Vive are out there, and where we've seen this virtual reality technology trend come from, it's been driven actually from gaming and online gaming and modeling is where this has been developed. But we found some really, really good uses in the construction industry. So I wanted to share with everyone today an example of something that we did with virtual reality, and it came from our Science Park project that we did at Georgia State University here in downtown Atlanta. It's about a 350,000 square foot, $125 million laboratory building. It housed teaching, research, and admin, all under one roof. Very complex project, very important project for them. But one of the biggest components in the building was the laboratory casework. This would be the tables and the benches and the drawers that are used in the laboratories, both to teach classes and do research projects. So what happened, and I'm sure many people on the call today can relate to this, from when the design phase of the project was completed to when it came time to actually order the casework and ultimately install it on site, they had quite a bit of turnover in terms of their faculty and researchers that had participated in that exercise before. So what we did was we created a virtual reality mock-up with the help of our architect and their model, to where we could bring in the new end user groups and actually walk them through their spaces virtually, so that they could see in three dimensions what each bench would look like, what each cabinet would look like, where they would sit, where are the fume hoods, etc., and then comment on that. And what we found was there were tons and tons of little changes that needed to be made. And for example, maybe we had a base cabinet that had doors that opened to the side, and we had a faculty member come in and say, well, what I really need here, I do need a base cabinet, but it needs to have stacked vertical drawers that we can lock so that each student in this lab can have a drawer to keep their materials. So we made all of these changes throughout. I mean, we went through every single laboratory, walked the users through using virtual reality, and we were able to make all these changes prior to ordering the cabinets and casework for the project. And we did an exercise because it was quite a bit of changes, but being able to do that at that phase and do it virtually, so that, you know, we take for granted as construction professionals and architects that everyone understands how to read blueprints in 2D. And many people do. But if it's not something that you do every single day, it can be difficult to picture what something's going to look like three-dimensionally when you're just looking at it on a 2D plan. So in doing this, we caught all these little tweaks and changes. We were able to do them actually at a credited price back to the owner. We actually gave money from our casework budget back to the owner, and ultimately, you know, get all these design decisions done right and installed correctly the first time. So what we did was we thought it would be a good exercise to have the casework supplier go through and give us a price to, if we had not caught these changes, to say, let's say we got to the punch list phase of the project, and we the end user started to walk through and they found all of these items that needed to be changed. What we found was the cost would have been about $350,000 at that time to make these changes. But just by using a little bit of technology that was easily at our fingertips at the right point in the process and with the right people, save the owner, you know, a ton of money and heartache at the end of the job by finding out that changes needed to be made. So this was a very good example of how we use technology to add a tremendous value for our customer. And this is, you know, a definite trend in the market, and there's tons of stuff out there.
And Ben, I'm sorry to interrupt. We had a question, but for Ben, if I can jump in just for a moment before we get too far from the talent and the training topic. We just had a quick question about what age group is targeted in the craft education programs that your company does, or maybe that you've seen across the industry.
That's an excellent question, and we definitely target people 18 to 30, I would say. You still have some people that are coming out of high school and are looking for craft training programs, so that's out there. But there's also there are also a lot of programs that are built for the young adults, ages 22 to 30, let's say, where, you know, they can come in and get skills that they need, both, you know, business skills, technical skills, things that they need to succeed that they wouldn't otherwise get. A good example that comes to mind there is Westside Works here in Atlanta. They are pulling in people from the inner city community that want to work but don't have craft skills. They bring them in and put them through a 30-day program that teaches them, how to be professional, business skills, craft skills, and other things of that nature, like safety, things that they need to know to be on a construction site. And then what happens is they have a class that comes through, every couple of months, and then we go down there and they have a hiring fair where we can go in and meet their graduates and then put them into our trades. So it's the age group, I'd say, is 18 to 30, but there's a lot of creative things that are being done out there to supplement this, and as a trend, I only see this increasing.
Thank you.
Any other questions on the technology topic?
Not at this time. Now I think we're going to hear from Tim. Thank you very much, Ben.
Thank you.
All right. Good afternoon, and thank you also, Ben. And I'm very excited about that technology part. I'm glad I didn't have to talk about it, but it really is what's changing our industry and making a whole new way of doing things. And that's kind of the point of what I'm going to talk about here today. There are Gordian, and our data, cost data, is developed around materials, labor, and equipment. And most of that is very much the same as it always has been. You need the doors, you need the bricks, and they have a cost to them. You need laborers and equipment. But as you can see with the virtual reality, I just happened to see an example the other day of a piece of equipment that actually lays block. So for a cinder block wall, and there's a machine that does it, and it does it perfectly. And everything in our industry is about on time and cost effective. It's always been the mantra, and that's what construction's all about. So in the Gordian data set, what we're talking about now is obviously we need to understand and track cost data for materials, labor, and equipment. But we have to stay on top of, and we are staying on top of, changes in productivity. What is it taking? Is it more equipment now than labor, or is it more labor to do certain things, and is there different kinds of materials going into buildings? So with that said, I'm just going to jump through this, and I'm assuming I have control, and I do. So we're talking about construction cost data, and this is broken up into 3 buckets, if you will. We're talking about data that people need in order to make more informed decisions about the market and the cost of the materials and the labor and equipment that we're talking about. And then predictive data. One of the identifiable issues that we found that listening to the feedback from the industry was our cost data was designed to give you information on, hey, I'm doing a bid today, and I need to know what kind of costs I should be putting into the budget. Nobody uses that data to do something today. They're always planning to do something for tomorrow. So with the expansive data that we have over the last 70-some years, we can take advantage of today's analytical databases and analysis tools to try and predict better what the costs are going to be tomorrow at some point in the future. And then enhance cost data analytics. Every time one of these technologies comes along and changes the process or conditions, as Ben talked about, 2 stadiums being built in Atlanta at the same time, that obviously had a cost effect on anybody else who was trying to build something in that marketplace. And we need to understand what those variables are, so that we can help people understand what they need to plan for on a budget because of that. So I'm going to move to the next slide. So as I was stating, construction costs are built from the basics. Materials the costs are based on commodities and manufacturing. If the price of steel at the commodity level goes up, it's going to trickle down at some point to buying a piece of steel for that building that we're looking at here. Labor cost and labor cost, as Ben was talking about, is based on supply and demand. If you can't find the labor that you need in the location where you are, you're going to have to reach out further or use different kinds of labor that are not going to have the same cost basis as a traditional craftsman that goes along with the job that, hey, readily available, we can use them, we know what we're going to pay them, there's a standard rate, and that's what the cost would be. And then this final thing is putting a combination of all those costs together with a rolled up with a productivity model that is changing every day with all this technology that we're talking about here. So that's kind of what I mean when we talk about construction costs and where they come from and what we're doing to enhance them going forward. And again, the primary question is, what is it going to cost tomorrow? So at Gordian, under the RS Means brand name, we are working on taking our historical data and trending that data and identifying good statistical models in order to predict what those costs are going to be in the future. There's two ways that we've explored to do this analysis and to come up with this data point is to use typical statistical modeling. The problem with statistical modeling and using all it does is use our historical trend and then do a statistical model to predict where it's going to be in the future. As you can see, one of the key points here is that it has a lag to it. So this was the actual cost, and then the predictive cost that catches up statistically after the fact. Where we are going more dynamically is into what we refer to from a statistical modeling process called structural causal model. And this one happens to be a representative of our metal materials database, and we are putting models against every type of material. So from metal to wood to concrete to architectural materials, and tracking all of those costs and building a model around each one that uses external indicators of cause and effect to look back in time and say, in the past, when the cost of raw steel increased, or the export and import, we exported it out of the country as opposed to importing it into the country, when did that have an effect on the cost to the street, to a contractor going to buy that material? And build a model around that so that we can then do that prediction. Just as you can see here, this is an actual model that we've developed, and this is where it's predicting the cost of, it looks at, that model goes in and predicts the cost of the prediction cost for that material versus what the actual cost was. And as an example, we're showing here in that recession that Ben was referring to that we all know about, when things dropped, we're looking to obviously predict this happening as opposed to waiting for it to happen and then react. Because this is literally where a lot of people, all those jobs moved off to other places because everything dropped through the floor and people were not, anything you had budgeted for now cost a lot less, and therefore we weren't getting paid what we should be getting paid for doing that work. What you do with them from a statistical modeling perspective is you take this, and we happen to also run that same model against the historical years. So you do it with a tested and training data set and a validate data set. So this is where we're showing the accuracy of this model, and quite literally on the next slide, I'll show it to you in a second, but quite literally what we're doing is taking a tremendous amount of external indicators and evaluating them to identify which ones of these economic indicators, construction industry indicators, start activity in the market, and then quite literally whatever material we happen to be working with. And these are just a sampling of some of the things that we actually look at to see how the statistical model can be built to give us a formula, which I'm going to identify what the cost of some material is going to be into the future. And we use the analytic information that I just talked about of that historical trend data and the comparison to actual, and then how we normalize the data, which I'm going to show you in a couple of minutes. So that's what data we're using in order to create this statistical model. And what it ends up doing is giving us a model by which we can see how that cost is being predicted in the future, and then being able to relate, well, based on that prediction, what was the variance of what somebody actually paid? Because there are two different types of data. One is estimating data. Estimating data is driven by a formula. It's material, labor, and equipment put together with productivity, number of hours, very structured and here's what the end result should be. So it comes out and tells you here's what the estimate should be, and it makes assumptions about what the profit margin is going to be and what your overhead expenses are going to be, what we refer to as O&P. In real world, there's a difference from that, because there is, based on what I refer to as local market conditions, that says, hey, because those, as an example, those 2 stadiums were being built in Atlanta, there was a higher variance between what the expected cost, estimated cost, and the procurement cost. So it's 2 moving parts is what I'm trying to get to. There's one where you can estimate what the, predict what the future costs are going to be, and then secondly, taking what's going on in the local market conditions and understanding how that is going to affect what the actual procurement costs are. And just to elaborate on that, obviously what I'm talking about here is the profit that someone is willing to take to get a job in 2009 was a lot less than as they started to move through, and we got back up there into 2013, 2014, and 15, a little bit less, but of what somebody was willing to take as a profit margin because of the market activity in that marketplace. If you need work, you're willing to do a less profit margin. Hey, if you're busy with work, you're going to have a higher profit margin. And we're trying to track that and help customers understand what those differences are and what do those cause and effect from an estimate to a procurement data. The other part of analysis that we can do for people is to help them understand where their costs are being spent. And this happens to be in the old master format category, but it's just easier to show sometimes, and a lot of people still use it. But to understand what the distribution of spend by each of the master format categories are on a given project. So in the typical elementary school, there's a certain amount of money based on modeling and also actual data that we track to see what the distribution of spend is for each of those components of the building. And what we normally do is help people understand, hey, here's the model, here's what you're seeing in the marketplace on an average, but any given single project may have a variance in that. And that's one of the places when you're negotiating a project and you look at the cost that someone has submitted to you, you can look at this data and understand, hey, you know what, you're at 14.4%. I should have had a better example, but 14.4% for wood and plastics when the norm is 13.9%. Where are we getting a distribute? Why are we paying more for wood and plastics on this particular project compared to what we normally pay? But this is, again, part of the analytics of the construction cost data that we try and use to evaluate how the distribution of spend modifies in real world versus a standard. This is kind of a similar added effect of the cost data, is looking at where it happens. And quite literally, part of our data set allows you to be able to look at data across various locations over time and see where your pockets of where you're paying above the normalized data. And what I mean by normalized data is that cost models that we have built for each type of building, you can then say this at this point in time, at some point in history, because this is actually over a 10-year period of time, we were able to take actual results and show that in these particular locations, when that person built their building, they paid an extreme amount against the model compared to a place, one of these other places, the green ones, were within one standard deviation that actually said, hey, you fell right within the expected normalized cost of that building at that point in time. But it helps users, construction owners and construction contractors determine where am I going to have an impact. And what one of our jobs is to help try to identify what local market conditions may have caused these outliers in your data set. Is it the way you went to bid? The methodology of your bid methodology that you used that Ben was talking about may have been the cause. Some of these may have been negotiated as opposed to, or then a design bid build, and that could be one of the effects, as well as like I said, the local market conditions, when extra work was being done in that particular marketplace. This is another way of looking at the data and analyzing it to provide information to a user so that they can understand what's going on with their costs. As I kind of alluded to and talked about the factors that drive cost change, obviously supply and demand. and raw materials and improved efficiencies. These are all having a major effect on construction costs. So that in quite literally, even from the perspective of how things are being put together, there's a lot of, one of the things that we've seen in our business is the impact of pre-configured module building. Prisons, as an example, one of the things is the whole prison room comes as a block, and they just stack those blocks together as opposed to a traditional build. So all of those things are impacting our productivity models. It still has more or less the same amount of concrete, but it can be put together and created into that block a lot more efficiently in the factory than it can in the field. As far as one of the things I wanted to make sure and get across is that the data that we put together is driven, as I said, from the bottom up, and that means every material cost, all individual materials are researched and found out what the cost of that, from that brick, that single brick that we're talking about, to a pallet of bricks, to doors, to windows. Each one of those is researched and tracked independently, is what you're seeing here on this escalation chart, showing it over the last few years for a given material and in a given location. Because one of the reasons that we have what we refer to as our construction cost index is because obviously in different locations there's different escalations of cost as compared to other locations. So we're trying to build a lot of tools for people so that they can understand it, see it, and then also we're using that in order to do our predictions. So the point here is that we're doing it at the material level. We're looking at labor costs, and labor costs that had to do with, as Ben was also referring to, either union labor versus open shop labor. And in different markets, we know we have a mix of those. And our tools try and help you understand what the implications of the cost of each of those is in the marketplace. And then literally the last part of it is to take all those pieces of material, labor, and equipment and roll with the productivity and roll them up into a model. Because many people talk in the world in reference to dollar per square foot trends. How much is it costing me to build a school on a dollar per square foot basis versus a Class A, B, or C office building? And what we try and do also is provide that information at a national level and at a localized level as a combined building. What are the cost implications? What's changing in those costs? This is nice to look at the dollar per square foot level, but quite literally, most people really do want to know, well, what was that caused by? Was it caused by local market condition, or was it the cost of steel going up, or was it the cost of the recession, and the impact from the recession? So there's a lot of data, and these tools today that we're using, much like the virtual reality, the analytical tools, machine learning, statistical analysis that can take millions and millions of data points and try to find the trends in them and use that data to enhance and come up with what the cause and effect was of any condition and what it's going to be in the future. So this is kind of the things that we're looking at. This is another example of the labor pool. This is analysis we do that talks about, based on the amount of commercial construction activity going on in every market compared to the number of construction employees that exist in that marketplace and what the trend year over year is. So in these are all, each one of these is sequentially by years, but we can see here in New Mexico where it was a 13% growth that then went to a 3% growth to and I forget the exact pattern on it, but we have them with years, but it basically gets up to a 22% negative. So that marketplace had a shift of the dollars of available construction compared to the number of people, and that has what we've proven is an effect on what the bid prices are going to be on those jobs in that point in time compared to what they were at this point in time. So there's, again, tremendous amounts of data and analytics that we can do to help people understand. And just in conclusion, I wanted to talk about the points to remember. Again, we research the material at the primary level. We normalize it to any time and location so that we can then look at history and then also do predictions to the future. We're obviously always looking for that variance to the norm, and the cost data that we work with is what we determine basically is that we try to build up benchmark data. So that's a benchmark. Here's what the median should be for what it's going to cost to use that material, or to what that labor is going to cost, and then apply what the other variance factors are to say what the difference is going to be to that norm, so that you can go from an estimate to a procurement cost. And again, that variance is what helps us drive with that predicted data. And we expect that this is going to keep evolving as more and more data is captured, and better forecasting is done, so that we can then have better inputs to our model. And we'll always improve as we get closer to any bid. We're going to, or any actual construction expenditure, we'll be able to get even more and more accurate as we get there, because the whole idea is we want to make sure that people have the best available data so that they can win jobs and make a reasonable profit at it, and help that both the owner and the architect and the contractor understand all those implications, so that everybody gets the best job done on time and under budget. And with that, I think, thank you very much.
Thank you, Tim. Thank you. Yes, with that, we do have a poll that we'll ask our attendees to answer, and then we'll get to all the great, or as many as we can, of the questions that you've all have sent in. So please take a moment to cast your vote here. How do you currently forecast construction costs for your budget? Those of you in the audience, do you use past estimates, third-party economic data source, third-party cost data source, your best guess, or you don't currently budget or forecast? Please take a moment to vote on that, and then we will get into the Q&A. And please be assured, if we actually don't get to one of your questions that you sent in, the Gordian and McCarthy speakers will go ahead and address them privately after the event. Not immediately after the event, but soon after. So please take a moment to vote there, and we will see the results in a few seconds. Okay, so 48% use past estimates, 32% third-party cost data source, and that's followed by don't currently and third-party economic data source. So thanks very much for weighing in on that. We appreciate it. All right, so we'll get into the Q&A. Let's see, we'd like to jump into maybe a broad question, and Tim, this may be best for you. Can you explain that these predictive data service that you've talked about here? Can you clarify how it is to be used? Can it be used by building owners for planning and budgeting purposes? How can they use it? So to rephrase that, can your program be used by owners for planning and budgeting purposes and estimating costs, in addition to contractors costing out a project for bidding?
Absolutely. And when you use our tools, basically, it always had, as the poll referred to, a lot of people use their past estimates. And number one, you could use a past estimate and adjust it and say, okay, what would this building have cost me in 2012? If I was, I built one in 2012 and I know what that cost me. In the Boris Means online tool, you can literally go and say, okay, here's what that cost was back in 2012, now bring it forward and say, what is it going to be today? Enhanced beyond that, now we're actually taking that so that you can then say, okay, but now I'm really planning this building for 2018, and it will allow all of the data pieces that you have, whether it's $1 per square foot or it's you have an itemized estimate at the unit line item level, and move all those costs and adjust them to that point in time that you're looking at in the future. So yes, it would be used by an owner and or by an architect and or a contractor to do this, make the same assessment. So it's all about how your estimate is put together, and then identifying when and where you want to build it. It will then adjust to what the cost is that we were predicting for that at that point in time. This also not only is for new construction, but it is also taking advantage of our new renovation models that, hey, I'm planning on upgrading this building, and I'm just going to do the paint and the carpeting, what we refer to as a level 1 refurbish. And that one, you would also be able to use that forward-looking knowledge and say, hey, I'm planning to do this in next year, so what are you telling me the costs are going to be at that point in time for that particular kind of work?
Thank you. And along those lines, we do have another question asking, how do you forecast factors other than commodities, such as fuel, for example?
Basically, we do use some external resources. There's people, quite literally, one of the data aggregators is somebody like Moody's, who does do models for each of those individual inputs. In the slideshow, I showed you a number of different indicators that we use, and they actually do a forecast for each one of those individually. All we're looking for is, based on that forecast of that, what fuel, as you said, could be then is in the formula that then predicts what we're expecting for the cost of roof shingles to be next year. Because that's part of the formula, and we've tracked that, and now we're using their best model. We're really only, our specialty is in the construction of materials and labor and equipment, and other people, we're using other resources to figure out what they're saying the cost of fuel is going to be into the future.
Thank you. Thanks. And let's jump over to technology. That was one of the trends you had all talked about. Obviously, either of you jump in, please, but maybe Ben could comment on this. I was directly asking, aside from virtual design and technology, what other types of technology is your firm using or are you noticing being used in the industry? And additionally, in your experience, who's bringing in the technology, for instance, virtual reality? Is it the contractor, architect, engineer, or a combination?
I'm going to actually answer the second part of the question first. I would say it's coming from all directions. You know, it really just depends on what the application is. I mean, I think probably the design firms and engineers are probably a little more versed in modeling, whereas the contractors are spending a lot more time on things like overhead coordination, taking their models and working with them to apply them to the actual construction activities. As far as technologies that we're seeing aside from virtual, I would say a big one is laser scanning, and this is not something that's really new, but it is something that has become much more cost effective over the course of the last few years. It used to be that you could laser scan for a relatively inexpensive cost, but it was very difficult to convert the output of a laser scan into a useful document or a useful format or model. Now there has been a lot of software developments done that make that a very simple and cost-effective process. So we use that in a number of different ways. Anytime you're doing a renovation of an old building or an existing building where the old blueprints or documents do not exist or they don't exist in electronic form, I mean, you can go in and very quickly laser scan above the ceiling or any type of existing conditions and develop a model to work from. We use laser scanning when we do new construction to pour concrete floors to check the flatness of the floor. Or if there was a pitch or elevation, to make sure that that we have poured it appropriately. We use it to check slab edges and things of that nature. So that's another place where we found a lot of added value to our customers in terms of quality.
Thank you. And now we have another question going back to the predictive data. The question reads, the engineering firm's estimate that this attendee uses is often used to gauge the cost. However, these figures are not 100%, and I believe it is because of the market cost information not being present. What can we do to ensure better estimates?
And that literally is what we're trying to do, is provide tools and that market information so that people can take that into account. Because when you're putting an estimate together, the bottom line is you have to make certain assumptions. And your assumption is, hey, I can find that laborer and there's plenty of labor resources. But in reality, you need to understand that it may not be the case. And secondly, you need to know the cause and effect of that. Is that going to make my project cost go up? So I think that's where we're approaching the marketplace from, market intelligence, from the analytics that we have to help people understand what the cause and effect of those variances are, in local market variances are, on the cost of what you're actually going to pay for that project.
Great, thank you. And another question here, how far out does your predictive data, I think you did touch on it, but how far out does your predictive data offering?
Currently, we feel that we have a good, reliable statistical model that's good for 3 years. And literally, we actually talk about it in 12 quarters. So based on our data being updated on a quarterly basis, it goes out 12 quarters is where we're comfortable with the level of accuracy that we expect to see.
Thank you. So I think we have time for one more question, and I guess I'll ask, let's see what we have here. For your labor, we'll touch on labor. For your labor cost forecast, do you have it broken out by region? And at this point, are you focused mainly on the United States?
We focus on the U.S. and Canada, and absolutely do it by region. Literally, we track it down to 978 zip code locations across the country. So there are differences in the data. That's part of what our construction cost index, CCI, as we'll refer to it as, makes that adjustment to every location in the U.S. and Canada at this point in time. We do isolated projects for places around the world, in particular for the federal government, and help them with understanding how would you adjust this cost for Dubai, as an example. But that they're normally it's really mostly of the federal and DoD type clients that want to know things like that.
Thank you. Thank you very much. Well, it does look like we're out of time, so I wanted to thank all our attendees for sending their questions and for participating today. And of course, thank you, Tim Duggan of Gordian and Ben Watkins of McCarthy Building Companies for this presentation today and for sharing your insights, and also to Gordian for sponsoring this webinar. A recording of the webinar will be available online at facilityexecutive.com, as well as on the Gordian website at gordian.com. Thanks again, everyone. And to reiterate, any questions that were not addressed will be addressed individually going forward. Thanks very much. Have a great afternoon.